Okay, so I got a question from a friend of mine on YouTube asking exactly how does an air conditioning system work as far as how the freon circulates in the system and whatnot. So we're going to go to one of my favorite websites, and that is howstuffworks.com. Right there it is. I'm going to go to that. I'm going to adjust my tripod so that you can see, and I'm going to type in air conditioner. Now, where's the link at? Hadn't been on this site in a while, you can probably tell. Maybe I should type in how an air conditioner works. There we go. Okay, so there's a diagram on here somewhere that I want to show you. Yes, right here. So just a second. Alright, so you can see this says hot coils, this says cold coils, compressor, and expansion device right here. This is the condenser coil, this is the evaporator coil in the inside unit in the air handler, or the evaporator coil on your furnace, and this is the condenser coil and the compressor in your outside unit. So we'll start at the compressor. At the compressor is compressing and squeezing that refrigerant, which is in a gas state, so it turns it into a high pressure, high temperature gas. So it's when you compress something, it raises the temperature, so it's going to get hot. So that hot freon circulates through the condenser coil, which is why the air conditioner outside blows out hot air when it's running in cool mode. So then the liquid line coming from the condensing unit is going to travel inside to the indoor unit where there's an expansion valve. Now this is either a piston or a TXV, which is a thermal expansion valve, which senses the temperature of the suction line and adjusts how much refrigerant it's letting in. And by the way, as the refrigerant goes through this condenser coil, it condenses into a liquid, so that's a liquid going into the expansion device. Once it comes out of the expansion device, out of the capillary tubes, it will come out of the small capillary tubes, which are about that big around. I mean, they're pretty small. So it's going to come out of that and then go into the evaporator coil tubes, which are about that big around, which is much bigger, and it's going to evaporate or expand into a vapor very fast, which makes it extremely cold, which is how the evaporator coil gets cold. And it's going to be a liquid that's going to be evaporating into a vapor the whole time that it's going through this coil, which is why the evaporator coil is cold. You have a blower that blows across the evaporator coil, and that's the cool air that comes out of your vents to air condition your home. Then the refrigerant goes out of that coil in a cold vapor state back to the compressor, where it gets compressed back into a hot vapor through the condenser coil, and the cycle just repeats itself. Now in a heat pump, this just completely reverses itself. You have a reversing valve, and I might try to find that in just a minute, a diagram of how it works. But you have a reversing valve, and the hot gas comes out of the compressor and goes directly to the indoor coil to heat it, and then it comes out of the indoor coil, comes back out to the condenser coil, and then in a heat pump there is a expansion device at this coil. So in a heat pump, when the heat pump turns from cooling mode, which is this right here, to heating mode, this becomes the condenser coil and this becomes the evaporator coil. That's why a heat pump blows cold air in heat mode and blows warm air inside when it's in heat mode. And yeah, just go to howstuffworks.com if you want to, type in up here how air conditioners work, and you have all these links here. And I'll show you window and split units real quick because it's got a cool diagram of a split unit. There you go. That's the typical split unit that you would find. See, you have the condenser unit with the condenser coil right there, the compressor, and then the indoor coil and the blower. And you can see the it's blowing the cold air up through those ducts. See, you got cold air coming out of the vent here and cold air going up through that duct, and you got the warm room air going into the unit to be cooled, going across that coil, just like I explained below. And there are your two lines going into the coil. Now this doesn't show the expansion device in here anywhere, but it's usually right when the lines go into the unit on the indoor unit. Actually, yeah, there it is. This is the line going in. There's the expansion device. Focus. There's the expansion device. It doesn't show the capillary tubes. Kind of does a little bit here. I mean, these small, they're very small tubes. And then there's your outdoor unit. Now, in this particular case, that's a straight cool unit because you see no reversing valve. So now let's scroll down. Here's chilled water. That's how a chiller works. And again, you can go to this website and look this up to see it for yourself. But that was how an air conditioner works. Thanks for watching. Okay, here's how a heat pump works. See, on the outside of an air source heat pump, like I said, see, now this is the cold coil. When a heat pump switches into heating mode, you have the same little diagram we had just a minute ago with the air conditioner. And so you have the compressor pumping its gas directly into here, which is hot, and you have the gas coming back out, going through an expansion device in the outdoor unit, which a heat pump has an expansion device. A straight cool air conditioner does not have an expansion device in the outdoor unit. And then basically the condenser coil in the outdoor unit becomes the evaporator coil, where the refrigerant is evaporating in a heat pump in heat mode and collecting heat from the outside air. There is heat in air down to negative 252 degrees Fahrenheit. Anything above negative 252 degrees Fahrenheit, there is heat in the air. May not be very much of it, but there is heat in the air, which is how heat pumps work. Now, a standard heat pump doesn't work below negative 10 degrees Fahrenheit. A heat pump will lose its ability to heat because they're not designed that efficiently. Some heat pumps are better than others, it's true. The more efficient your heat pump is, the lower temperature it's going to be able to work. So now let's just click next. There you go. A fan pulls the outside air over the coils. Liquid in the coils absorbs the heat in the air and expands into hot vapor. So now you can see it shows the fan pulling outside air over the coil. Click next. See, just like I said, the compressor is now pumping its hot gas to the indoor coil, making it hot, and the fan's blowing air over it to heat the house. Now, like I said a minute ago, sometimes heat pumps don't work that efficiently in cold weather. That is why, if it's known to get real cold where heat pumps are, typically in the air handler there'll be backup electric heat strips. Some people have dual fuel systems, which combines a heat pump and a gas furnace. The heat pump is more efficient when it's in the 30s, 40s, 50s out, and down below 20 the gas furnace is then more efficient. But as you can see there now, that has become the condenser coil, and now that is the evaporator coil when a heat pump runs in heat mode. That's why a reversing valve is called a reversing valve, because it is a valve that completely reverses the flow of the refrigerant and reverses what the system's doing. Long story short, when a heat pump is running in heat mode, it's taking air it's taking heat from the outside of your home and taking that heat and moving it to the inside. When a heat pump is running in cool mode, or when just a regular air conditioning is running, it is taking heat from the inside of your home and moving it outside. That's all it's doing. It's not creating coldness, it's just transferring heat to one location or the other. So now let's hit, well, let me let you read this. This vapor is put through a compressor, which increases the temperature and which increases the pressure and temperature of the gas, and the vapor flows to the indoor coils, as we can see there. The refrigerant condenses back into a liquid as it cools and flows outside to pick up more heat. So now you can see the air being pulled in from the house, being heated, and as the refrigerant goes to this, it's condensing back into a liquid, and it is pumped back out to the compressor unit, back out to the condenser heat pump unit, where it can collect more heat, and then it transfers back inside, and the cycle repeats, just like I said with the air conditioner. Basically, a heat pump running in heat mode is air conditioning the outside. That's why this unit, the outside unit of a heat pump, that's why it blows cold air when the unit is running in heat mode. The heat, meanwhile, is pumped into the air ducts of your home and distributed throughout the house, which is what a central heating system is. As you can see, it's showing that it is heating the home. So now we'll hit restart, and then it just restarts the cycle over. You hit start, and it just starts you. So that is how heat pumps work. Now, again, you can go to this one if you want to and check out this. I love it how they erase the name off of that, but if you know anything about HVAC, you'll know that that's a Carrier Infinity unit. But yeah, that's that could be a heat pump or a straight cool unit. You can't tell a heat pump from a straight cool unit just by looking at it. You have to look down inside it and see the I don't know what that was, and see the reversing valve. Here we can look at pros and cons of heat pumps. But yeah, if you want to write this down, and you can go check this out for yourself. But yeah, that is how an air conditioner and a heat pump works. Let's see if we can find how gas furnaces work. You should know how gas furnaces work. I mean, it's pretty basic. Yeah, it's just like maintenance and stuff. But that is how heat pumps work and how an air conditioning system works. Thank you for watching. Hope you enjoyed the video. Hope you learned something. Please subscribe, comment, all that good stuff. Hope you enjoyed. Over and out.